Okay, so this is the Carpenter DRA working group meeting for August 7th. Yeah, I guess we can go ahead and get started. So I don't think I have a ton to discuss this week. I mentioned as we were talking before starting recording the meeting, one of the large focuses for me has been reviewing and helping get node overlay out the door. And once we do have node overlay merged, we will be able to start building upon that for DRA. That's where a lot of my focus has been, though, so I haven't made much progress in terms of working on writing the RFC, though I'm happy to brainstorm in this meeting. Yeah, I guess, Alima, anything you want to add?
Not really, other than just gonna, and I mentioned this before, just gonna respond to your comments on that first PR.
Mhm.
Um, and you were also talking about you kind of have an idea for the architecture, even before Node Overlay gets wrapped up. Um, for that, is it just gonna be straight up just writing it in the RFC, or would that be like separate from the RFC?
No, so I think the RFC, in my mind, should consist of two sections. The first section would be focused so mostly on user experience. This would be like, how do you configure Carpenter to be DRA aware? What does it look like?
Mm-hmm.
How does Carpenter determine which instance types can satisfy a resource claim request, etc.? So more of the user-facing side of things. And then also have a section on the implementation side of things of this is where we plug into hydrate cluster state. Um, this is the different interaction points it has with the scheduler and the provisioner. Um, Potentially, like these are considerations we have to have for deprovisioning, like consolidation drift, etc. Um, so that's less user facing and more what do we actually need to do for the implementation.
Mm-hmm.
So, like, I think one of the early things that we could probably start working on that we're not necessarily blocked by anything else on is um, one of the things that DRA explicitly doesn't handle is tracking the allocation of devices in a resource slice. So, like with some other APIs, you might expect like the resource slice might have a status, and that status indicates which devices on the resource slice have been consumed and which have not. DRA explicitly opted out of that, so we are going to need to track that ourselves in memory. So starting to build out the informers that basically hydrate cluster state with this is the set of resource slices, this is the set of resource claims, this is how these resource claims have been allocated to these different resource slices. That way we can understand like, okay, this resource slice still has this device available that can be used in provisioning and so on.
Mm-hmm.
So I think that's probably like the it has the least dependencies and can be kind of implemented in a standalone fashion. Um, so I think that's honestly going to be the first big thing to implement after we get your first change out the door.
Okay. Wait, this is tracking tracking which resources have been consumed on specifically on the resource claims or both, right?
Um, I think we it's a good can device. This I don't know off the top of my head.
Uh-huh.
So if you have a resource claim on a pod, a container has a request for that claim. Can a container then only request a subset of the devices consumed by that claim? I didn't think so, but I could be mistaken.
Mm-hmm.
I'm coming off memory. So
Okay.
I think regardless if that is the case, then yeah, we need to track both. If that's not the case, then I think the main thing we need to track is a resource claim is going to claim some devices from a resource slice. We need to be able to keep track of in memory which devices in a slicer are still available and which ones have been consumed by various resource claims. Because we need to be able to understand if we have like a new pod that's pending and this pod has a request on a resource claim, can it get devices from existing resource slices in the cluster? Or will we need to create a new instance which supplies a new resource slice to satisfy that claim?
Hmm. Wait, I'm just looking at the notes from 2 weeks ago because I think we kind of mentioned this, right? Um, let me see.
I don't recall us talking about this specific
Or
issue.
uh, okay, okay. Or sorry, I guess I was thinking about cluster state, and then, but that is only tracking if the source of truth is that node or node claim. But I also thought maybe when we were talking about cluster state, we were also talking about if the resource, um, like if the cluster state is also tracking which devices have been claimed or available on the resource slices.
Well, that's what I think we would need to do.
Okay,
So
yeah.
that's what we would need to extend it to. Like, of course, we don't do that in cluster state today because DRA is not
Yeah.
supported. But yeah, I mean, generally speaking, cluster state is just
Hmm.
the source of truth for this is what the cluster currently looks like. These are the relationships between all of these different objects. And yeah, we maintain that in memory.
Hmm.
Is the source of most of Carpenter's memory consumption.
Hmm. Yeah, sounds good.
Yeah, the other thing API wise, I realized because at least I was envisioning we could basically just embed a resource slice into the node overlay directly. We do need a slightly different, um, we do need a slightly different way to express it, I'm pretty sure. Um, because for example, like with a resource slice, let's say you have a resource slice and like the general case, for example, is relatively simple. The resource slice is available to any pods that share the same host.
Hmm.
Um, we need a way to kind of template in that this is the host for the node that we are creating from this resource slice. Now, with host, I think that's relatively straightforward as a special case, but you have to do the same thing with like, let's say you have something that is only available within a zone. Or within some other constraint. Like they need to be on the same rack, like some other topology key. We need to be able to support some level of templating, I think, which means we probably won't be able to express the resource slice at least in a one-to-one way with the actual upstream manifest. Like we basically need a way to say, like there could potentially be two ways to say it, like this resource slice will only be available, or you can only binds to it if the pod is in US West 2A, like has an availability zone, or say it doesn't matter what availability zone it is. It just needs to be in the same availability zone as what this node is created in.
Okay. When you say that, I had the preconceived notion that that can be done with like taints and affinities
So we need a way to actually express that
on
on the
the
source
resource.
slice, though. It's not a matter of pod scheduling.
Okay.
It's a matter of making Carpenter aware that basically making Carpenter aware of the topological constraints for a resource slice created for a given instance type.
Okay,
So like maybe
okay,
a
that
more,
makes sense. Yeah, yeah, yeah. Yeah.
yeah, a more pointed example would be like with these B200, or is it HB200? GB200.
GP
Yeah.
200.
So you might have multiple instances which are part of the same GB200 rack. And um, pods can only share a resource slice if they are on that same rack, for example.
Mm.
But what if you wanted to launch two GB200s, like two GB200 racks or instances that are on different racks? Like you need to be able to understand, okay, these pods can only schedule together if they're on the same rack as one another, if that makes sense. And we
Yeah,
don't necessarily know what the concrete value of that rack is until we launch the instance. So we need some way to do like templating, similar like we for topology spread constraints, for example, for new nodes, we always inject a fake host name to support that. So we basically need to be able to do something similar.
okay. Can you explain more about hosts? Because this is my first time hearing that term in the space.
Hosts, just a note in this case.
Okay, but uh that whole idea is just a node where, like, I think you said pods have to share the same host. Um,
Yeah, so like you can imagine in the default DRA use case, like the most basic is you just want to get a normal GPU. So if you have a pot, so the resource slice that is created is associated with a specific host name. So host name is like the identifier label for a specific node in Kubernetes. For the pod to be able to consume, or for the resource claim for that pod to be able to consume a device from that resource slice, the pod needs to schedule to the same host that the resource slice selects on.
okay, okay, yeah, yeah.
But of course, that can be expanded from it doesn't need to be a host. It could be that they need to be in the same AZ. Could be that they need to be in the same rack, same spine, something along those lines. Like as far as I can tell, DRA is kind of infinitely flexible here. You can use any label you have in Kubernetes to define these. Of course, there's going to be a reasonable set of labels that people use in practice,
Hmm.
but theoretically it could be anything.
Okay. Um, okay, so the main idea is that the host identifies the node. Is that right?
Oh, sorry. I was reading a message.
Oh, it's okay, don't
Um,
worry. I was just asking the main idea is that the host is the identifier for the node.
yeah, generally speaking.
Okay.
I'm not aware of any edge case where that's not the case, at least in AWS. Maybe there is in some other cloud provider.
Okay.
Um, but my understanding is typically your host name is going to be a unique identifier.
Mm. It's like host name. That's so I'm just looking at it in the code. It's a host name in node claim.
Yeah.
Okay.
Yeah, but I mean, host name is a standard Kubernetes label.
Okay.
So it's not a Carpenter specific concept.
I see. Okay. Um, okay. Thanks. And I feel like I have a good idea of that. So these two things, which are kind of like the next things to be implemented that are like standalone, will be next. Usually for a big project like this, or like an effort that's gonna take like multiple parts, is it usually things start getting implemented and then continue to be architected? Like for example, we're just doing the first PR where it's just like a bug fix, right? But then these two standalone um like things to be implemented, would it be already being worked on and then we continue like architecting the rest of it like simultaneously, or do you think the whole thing needs to be kind of architected first before we even try these standalone?
So I think we do need a better idea of what the rest of the implementation is going to look like before at least starting on either of these tasks. The second one is blocked and node overlay. We need node overlay in first
Mhm.
before we start expanding its interface. And then the first one, I think more than likely we could begin implementation pretty immediately because I think there's only so many ways you can do it, and it is something that kind of by definition needs to be done. Um, that being said, it would still be good to kind of define the interfaces that scheduling needs from cluster state, because that might affect the way that we actually store the data inside of cluster state. Uh,
Mhm.
so yeah, no, I wasn't raising it as we can get started on this immediately, but
Just
or as
opening a
this is
conversation about
something
it.
that, yeah,
Okay.
this is something that is going to be in the RFC and is probably going to be one of the first milestones to hit is getting that implementation in place. I think the main thing too is I'm trying to figure out ways we can shrink these PRs. Like
Mm-hmm.
I know we've felt this with a few of the larger features we've merged in as of late. Node overlay being one that's like 4,000+ lines. Um, Reserved capacity support, I think across both the AWS provider and upstream ended up being like 6 or 7.
Yeah.
So trying to keep review manageable, um, especially because GitHub's not necessarily great at showing like a diff between two revisions of a PR.
Yeah.
Um, yeah, I'm trying to think ahead about how can we split this up to keep review manageable and keep some decent velocity. But yeah, then other than that, I'm really just brainstorming.
Mm-hmm. Okay.
Yeah, because after that, though, I actually think the scheduling aspect shouldn't be all too complicated. Um, Once we have all of the tracking in place. I think what will get a little bit more complicated is potential later integrations with, say, different DRA drivers. Like, I think the long-term vision, at least for AWS, is we don't necessarily want customers to need to configure these resource slices on node overlay. Like this is a good way for us to get an initial implementation out and have people be able to use it, but that's a lot of configuration overhead. I think in an ideal world, we should be able to discover from, like, let's just say, for example, the NVIDIA driver, like, okay, we know you have the NVIDIA driver installed. We know that for these instance types, these resource slices will be created based on this configuration.
Mm-hmm.
I think worst case, this just is something that is implemented on an ad hoc basis per cloud provider. Um, And there needs to be some level of cloud provider integration because, of course, each cloud provider has their own instance types. Um,
Is this so I think I've heard of like there's like a DRA example driver.
mhm.
So that whole idea is it's an example DRA driver so that way like it's kind of standardized, right? Um like for all the cloud providers. Um
Well,
no? Let me look.
um, I don't know for sure on the example DRA driver, but things can't be 100% standardized because like at the end of the day,
Even with that we would need
like
to do like the ad hoc work.
AWS and Azure have different instance types.
Okay.
We're not going to be able to provide the same strings to some API and get back like this is what your resource slice is going to look like.
Hmm.
As far as I know, the example DRA driver was simply an example for how you would go about putting together a DRA driver for some hypothetical device.
Okay.
Um,
Yeah. Okay.
so, but generically, like what we need from like an AWS context, for example, is I have this instance type. I want to know what resource slice will be generated for it before that instance type is created. And that's kind of the tricky part. Like I don't know if CAS has any plans to be able to do scale to zero um, with DRA. But one of the things that they can do, I've not looked at the implementation, so maybe they do this a little bit differently. But the way that I suspect it works is you already have an instance of that type. You know what resource slice was created for that instance. So you can just expect as you scale up the node group, you will get more of the same resource slice. I may
Hmm.
be grossly oversimplifying, but
Hmm.
I believe that that is how it works. Since we are essentially ad hoc generating, like provisioning not random instance types, but we're selecting from a set of, in AWS's case, nearly 800, rather than just the ones that have already been launched into the cluster. We need a way to figure out what does this resource slice look like based on the configuration of your whatever DRA driver you have in your cloud provider. And I think maybe this just ends up being like each cloud provider ad hoc and implements this as part of the cloud provider implementation. Like you can imagine in the AWS provider, we just detect, okay, you have the NVIDIA driver installed. This is all of your configuration. We're going to start injecting these resource slice objects into the instance types that we return back to upstream Karpenter. Um,
Hmm.
but it would be, I've been thinking about ways that we may be able to either share some of that burden or at the very least make it a little bit easier to implement. I haven't thought of anything great as of yet. So, but yeah, that's something else that's worth thinking about. That's pretty much all I've had for this meeting, though.
I just like put all my notes into the working group. Um, okay. Okay, sounds good. Yeah, I just need to clean up the notes, but I was taking notes from the past on the RFC, but I think would rather it just be in the working group log and then keep the RFC clean. Um, yeah. I mean, I don't have anything. I just need to work on the PR. I had to like context switch earlier this week, so I've been working on some other stuff. But yeah, I'll get to that probably on Wednesday.
Okay, sounds good.
Mm,
Yeah, no worries about context switch. I don't think anyone expects that either of us are spending 100% of our time on this.
hmm
So,
Yeah. Um, yeah, but I want that to go in sooner than later. Is
mhm. I think it's close. So,
Yeah. Well, I didn't look at your comments. I actually don't know how close it is, but I hope.
none of them were super major. A lot of it was more code organization.
Okay.
Um, there was one thing about like some spurious logging. Um, yeah, there was nothing major in this round of review. I expect once you address all of those comments, we should be able to get it in.
Okay. Yeah, if I have a question, I might Slack you.
Yeah, feel free.
But in terms of what we talked about in the working group, like did it match up?
More or less, I think the one thing was I think we were saying feature gate. It probably shouldn't be an actual feature gate. It should probably just be a CLI slash environment variable, like CLI flag or environment variable.
Okay.
Um, the reason being is it is not a feature that we are driving to graduation.
Gotcha.
Eventually, we'll introduce a DRA feature gate, but I think it makes sense for this to live as like just a separate option.
Yeah.
Then also being explicit about the fact that not only is this like considered alpha, but we intend to drop this once DRA is shipped. So
Okay.
making sure that if just doing our due diligence and making sure that if anyone starts to depend on this, or anyone who starts to depend on it does so knowing that it is going to be dropped at a future date.
Uh-huh. Sounds good.
Okay. Yeah,
Yeah.
unless there's anything else, I think my plan for next week is to still basically finish up that user story draft for the RFC. I also want to start writing up what the node overlay integration will actually look like. So think through that, what that templating needs to look like, and then possibly be able to start looking at formally writing up like, okay, this is what we need to do for cluster state. This is how it integrates with scheduling. I think that's going to be a stretch, just given the other things on my plate at the moment, but that is what I'm going to be pushing for at least.
Okay. Sounds
So,
good.
all right.
All right. Thank you so much.
Yeah, no problem.
Uh,
I'll go
yeah.
ahead
See you
and
around.
stop recording.